All right, math people, here we go. We got lesson 10-6, intercept form. Our question for today is explain why x plus 1 times x plus 2 equals 3 cannot be solved by these two equations, x plus 1 equals 3 and x plus 2 equals 3. You're going to see why later on people are tempted to do that. It doesn't work, but that's not possible. We've already had two forms of quadratics so far. We've had standard form, and we talked about how in standard form, the a value told us that if it faces up or down, so if a is positive, then our graph faced up. If a was negative, then our graph faced down. We also talked about how a is kind of the strength of the graph. Again, every single lesson I do, the stupid lights turn off. It's probably because I'm here so late. Anyways, where was I? Ah, yes. We talked about how the A was kind of like the strength. So a big A is really strong, so it pulls the sides of the parabola together and it makes it narrow. And if A is small, then it's weak and it makes the sides of the parabola, go, wide out there. So the stronger that is, the more it pulls those two sides of the parabola together. So the bigger the A value, the more it pulls them together. And we've actually kind of looked at how C was a shift, moving it up and down. We're actually going to see, after we've talked about intercepts, that C is the y-intercept. So the A value, when it's positive, it faces up. When it's negative, it faces down. Also talks about the strength. B, we're going to get to that in the next unit. The C value is our y-intercept. We've also done vertex form. A is the same as this over here, so that's the same thing. But then we found out that the vertex was h comma k. So that was vertex form. So it's a really quick graphing form. It's the best form to use if you want to graph something. And now we've got our third form. We're going to call it intercept form, sometimes called factored form. And then like in Math 3, sometimes they call this standard form, which is kind of crazy, but whatever. We're going to call it intercept form, also called factored form. It also has A. A always means the same thing. So every form that we are having is going to have an A in it. And it's always going to mean the same thing. Positive faces up, negative faces down. Bigger A, it's stronger. So it's pulling those two sides together. Small a, that means it's weak. It's going to let the sides kind of flop out and it's going to be really wide. But now we have two new things, x minus p and x minus q. So the p and the q are the x-intercepts. All right, now remember in the formulas, if it says x minus p, the minus part means we're going to take the opposite of whatever's in there, and that's what p is going to be. And we're going to take the opposite of q, and that's going to be one of our x-intercepts. Okay, what we're going to use today is what's called the principle of zero products. The principle of zero products is very simple. It just says if I'm multiplying two things, so here I'm multiplying a times b, and when I multiply them, that's what a product is. If the product is 0, then one of two things had to have happened. If I'm multiplying two numbers and I got 0, then that means either the first number is 0 or the second number is 0. Because if you're multiplying and getting 0, one of these numbers has to be 0. So either the A is the 0 or the B is the 0. So here I go. I've got two things that I'm multiplying. I'm multiplying 3x plus 1, and I'm multiplying x minus 8, and they equal 0. The principle of zero products says, well, if that's happening, either this equals 0 or that equals 0. Because the only way to multiply two things together and get 0 is if one of these is 0. So I'm going to write two separate equations. 3x plus 1 equals 0, and x minus 8 equals 0. Those are my two possibilities. This one's 0 or that one's 0, because I'm multiplying and I'm getting 0. So we're going to solve each of these. I'm going to subtract 1 from both sides, and I get 3x is equal to negative 1. I'm going to divide by 3, and x is negative 1/3. Over here, I'm going to add 8 to both sides. So I get x equals 8. So there's two solutions to this problem. X could be negative 1/3, or it could be positive 8. Remember, these solutions are our x-intercepts. So if this were a graph, it would be crossing the x-axis at negative 1/3 and positive 8. We also call these the zeros of the function. We also call these the roots of the function. So the solution, the zeros, the roots, the intercepts, it's all the same thing. There's two of them. They're at negative 1/3 and positive 8. Next one, I'm still multiplying two things. I'm multiplying x and x plus 6. So I'm going to set them equal to 0. X could be 0, or x plus 6 could be 0. I've already got one of my answers. X could be 0. My other answer, I can subtract 6 from both sides and get x equals negative 6. So my two answers are 0 or negative 6. These are our x-intercepts, or the roots of our function, or the zeros of our function, or just the solution to this equation. Okay, next one. It's not in factored form or intercept form. So we don't have these where the x is by itself. So what do we do? What we're going to do is we're going to factor them. So we're going to pull out our old factoring methods and factor this side of the equation. So I got to ask myself, well, what multiplies to give me negative 10, but adds to give me 3? That means I could do like negative 1 and positive 10, because those multiply to give me negative 10, but they don't add up to give me 3. So let's try negative 2 and positive 5. Aha! These two add up to be 3. So I can say that this factors into x minus 2 and x plus 5. So those are our two factors. And now we're going to use the principle of zero products. X minus 2 could be 0, or x plus 5 could be 0. So let's find our two answers. X minus 2 could be 0, or x plus 5 could be 0. So I'm going to solve these. I would add 2 to both sides. So my x could be 2. I'm going to subtract 5 from both sides. So my x could be negative 5. You see how we're taking the opposites up here? So I'm not taking negative 2. That's not my answer. My answer is the opposite. It's positive 2. Here I've got x plus 5. My answer is not plus 5. It's negative 5. I'm taking the opposite. That's why in the formula it's x minus p and x minus q. So we take the opposite of those two. So there's my two x-intercepts. X could be 2 and it could be negative 5. All right, let's factor this next one. So I've got two terms. I always look for a GCF first, and there is one. They both have x's. So I'm going to factor out an x, and I'm left with 6x minus 5. I have two factors. X is a factor. Remember, factors are just things that are multiplied by each other. I'm multiplying x and this stuff here. And my other factor is here. So I'm going to set them equal to 0. X could be 0, or 6x minus 5 could be 0. Over here, I'm going to add 5 to both sides. And I get 6x equals 5. I'm going to divide by 6 on both sides. And I get x equals 5/6. So there's my two answers. 0 is an answer, because x could be equal to 0. And 5/6 is an answer. And if you plugged in 0 to both of these, you'd see you get 0. If you plug in 5/6 to both of these, you'd see that, yes, you do get the correct answer. All right, I think we've got a couple more, and then we're done with this one. All right, so this one says find the x-intercepts of the function. We have to go back and remember what x-intercepts mean. X-intercepts means that y is equal to 0. And we have to remember that f of x, that's y. So for this problem, I would just go, oh, this is 0 equals 16x squared minus 25. Now, could I solve this by taking square roots? Sure, I could add 25 to both sides, divide by 16 on both sides, and then take the square root of both sides. Or this one factors. So I'm going to factor this one. This is the difference of two squares. This is 4x plus 5 and 4x minus 5. These are my two factors. I'm multiplying these two together. So using the principle of zero products, one of these has to be 0 because I'm multiplying and getting the product of 0. So I get 4x minus 5 equals 0. And I get, no, it's supposed to be plus 5. And then I get 4x minus 5 equals 0. So I would subtract 5 from both sides. Get 4x equals negative 5, and then divide by 4 on both sides. So one of my answers is negative 5/4. On the other side, I would add 5 to both sides. And I get 4x equals positive 5, and then divide by 4. And x is equal to 5/4. So I have two answers. Negative 5/4 could be one of my answers, and positive 5/4 could be one of my answers. Both of them work. So there are two x-intercepts. One of them is at negative 5/4, 0. The other one is at positive 5/4, 0, because we plugged in 0 for y when we do the x-intercepts. Okay, this one says find the roots of the equation. Roots of the equation are the solutions to the equation. They're the x-intercepts of the equation. It's all the same thing. So what I'm going to do is I need 0 on one side of the equation. You can't use the principle of zero products unless you have a 0. I can't just factor out an x and then set my two things equal to 35. It's called the principle of zero products, not the principle of 35 products. So I have to have 0 on one side of my equation. So I'm going to subtract 35 from both sides. So I end up with 2x squared. Let's do it in blue because it'll look pretty. 2x squared minus 9x minus 35 equals 0. Okay, now I have 0 on one side of the equation. So now I can factor this side. I don't have a GCF, and I have a leading coefficient. So that means that that number there has to be made up of, in the front, 1 and 2, and in the back, negative 35 could be 1 and 35, and one of them would have to be positive, the other would have to be negative, or 5 and 7, and one's positive, one's negative. I think I see what the answer is going to be. So let's set them up. So here I would put 2x and x. And then I need to find a combination that gives me negative 9. So if I put a negative 7 over here, these two would multiply to give me negative 14x. And if I put positive 5 right here, these two would multiply to give me 5x. And negative 14x plus 5x is negative 9x. So I got my factoring right. Now that I've got it factored, I can use the principle of zero products. This can equal 0, or the x minus 7 could equal 0. So let's write down our two possibilities. So we can do 2x plus 5 equals 0, or x minus 7 equals 0. So we subtract 5 from both sides and get 2x equals negative 5. Divide by 2, we get negative 5 halves. Over here, I would add 7 to both sides and get x is equal to 7. So I've got two answers. My answers are negative 5 halves, or negative 2.5, and 7. There's my two answers. That's all I got, my friends. So remember, our question was, why can't we just set these equal to 3? Because it's the principle of zero products. I have to have 0 on one side of the equation first. Okay, that's why this does not work. I have to have 0 in order for that to work. All right, math hard, my friends. I will see you later. Bye-bye.